Hi everyone, I have a update and I'd like to share that with you. So here's my original coil that I had in the test 7, and what I did is I made a second coil, and here it is, and again it's got a 3 coil pickup on it, and the reasoning behind that is to try to find, is it basically some other kind of thing happening with this, or if I add another coil, will it keep increasing in energy? And what I found is adding another coil does definitely keep increasing in energy. And I'll demonstrate that. So what I've done is the first original coil here has its own 6,000 microfarad capacitor, which is attached to the this one here is the 10 ohm resistor. Alright, 10 ohm at 1%. And the second new coil here is attached to the other 6,000 microfarad capacitor, and it has a 5 ohm resistor, which is also 1%. Okay, so here at the meters, this is our voltage input at the time that this capacitor is charged, which is monitored by the AC side of the bridge rectifier. So that's on the milliamp scale right now. Nothing's being drawn now because the circuit's not in operation. And this meter here is going to display what coil number 1 charges that capacitor to with that 10 ohm load, and this other meter here to the left will be what the second coil will charge that 6,000 microfarad capacitor to the 5 ohm resistor load. So this one will display a lower voltage because the load is 5 ohms, and this will display a higher voltage. And what I've done also, just to make sure that this meter is really kind of, really giving me a reading that's true, I attached a 12 volt automotive bulb in series with my positive lead, okay, that I would normally attach to this capacitor. All right, so we're dissipating heat or watts in this bulb, but I won't even calculate that, but I'll show it to you for the brightness and all that kind of stuff. So I'll go ahead and power up the circuit right now. So here you go, the circuit. What I'll do is I'll tune the my signal generator so that the circuit is drawing 35 milliamps, and that'll be a good okay, so there you go, it's at 35 milliamps. At 35 milliamps, the voltage input is 47 volts, and coil number 1 is being charged with the resistor to 3.56 volts, and the coil number 2 at 2.24 volts. Alright, and that's at 35 milliamps. And our light bulb is just basically glowing. Alright, there's hardly any light coming off of that. And the coils are in operation, and if I disconnect the coil, watch the bulb. Absolutely no difference. The coil is disconnected, see the voltages are down. Alright, and that bulb still stays glowing. And what I'll do is I'll connect it there. Voltage is back, and the bulb didn't change. Disconnected, connected. Alright, so it's not changing, and obviously you're seeing that it's charging the capacitor with the load attached to it. And these are the readings, and if you make the calculations to that, which I've done here, it's 47 volts input at 0.35 amps, gives a total of 1.65 watts. That's our input power. Now if we take our, well, it's higher right now. All right, it's at 3.5657. It varies, I don't know why, but it varies. Anyways, I've used 3.5 volts divided by our 10 ohm resistor gives us 0.35 amps. And our 0.35 amps multiplied by the voltage, 3.5 volts, gives us 1.225 watts. The coil number 2 is outputting at this time 2.26. When I did the math, it was outputting 2.22. We divide that by 5, gives us 0.44 amps. 0.44 amps multiplied by 2.22 volts gives us 0.986, a total of 2.21 watts. We deduct our 1.65 watts, all right, which is minus there. So we have a total of 0.56 watts over. So this circuit is actually now over unity, and that's not calculating what this the amount of energy that's being dissipated in this bulb. That's not being taken account for. So what I'll do is I'll pause the camera, I'll disconnect this bulb, and we'll look at the numbers once again. Hang on. Okay, so the bulb is out of the equation right now. All right, the coil is connected. It's connected directly, sorry, to the capacitor. All right, and what I'll do is I'll just retune a little bit again, so that we've got a round number here. All right. Okay, so there we go. We have our 35 milliamps, and this is what the output is. All right. So when I had done the mathematical equation for that, this is what I had. So 47.1 volts. I had 47.2 at 0.035 amps. It gives a total of 1.652 watts. That's our input power. All right. And at the time I had tested it, it was 3.88 volts. Right now it's actually higher. It's 3.93. I don't know why, but anyways, it's producing better power at this time than what we're going to actually calculate. So here we go. We're back here. Okay, 3.88, and we divide that by our resistor, and we have a total of 0.388 amps. Multiplied that by our input voltage equals 1.5 watts. That's on coil 1. Coil 2 is outputting 2.4344, and that's what I had at that time as well. And divided by our 5 ohm resistor, 0.486 amps, multiplied by our sustained voltage, and which is 2.43 at the time, 1.18 watts. So our 1.5 watts plus our 1.18 is 2.68 watts total that it's outputting, minus our 1.65 watts from the top. So minus our 1.6. So we have a total of 1.03 watts over. So the circuit at this time is producing 1 watt more power than what is going in. So if somebody can explain to me how this could be possible, since over unity is not possible as far as science is concerned, I am very open to your opinions, and thank you for watching.